Hello everyone, welcome back to another hands-on session. This is Jason Baker, and today we are going to take a look at VPCs, virtual private clouds. We've been using VPCs every week as we've been launching EC2 instances. However, we've been using a default VPC that's provided for us. This week, we are going to begin using custom VPCs that we create ourselves. And this is a very common pattern. It's generally when we build and deploy production workloads in our organizations, we're almost always deploying those workloads into custom VPCs. That's a best practice. We rarely, if ever, use a default VPC. Why is the default VPC there? Well, when we create a new AWS account, AWS automatically creates default VPCs in each of our regions, and that makes it easier for us to quickly launch new EC2 instances because there's a VPC we can launch the instance into. The default VPC is basically used as a training and learning mechanism, but it's not something that we should use on a day-to-day basis in our organizations. Let's start by creating a new VPC. I'll go to the VPC dashboard by clicking on the VPC link on my console or searching for the VPC dashboard. And you'll see a dashboard that looks something like this, where it displays all the different resources that VPC related resources that have been created in my account. I'm in US East.1 region right now. If I click on the Your VPCs link on the left-hand navigation, you'll see that there is an existing VPC. If I scroll to the right, there's an attribute called default VPC, and this existing VPC has a value of yes for that attribute, meaning that this VPC that we're looking at right here is the default VPC that AWS automatically set up for us. We're going to create a new VPC by clicking on the Create VPC button. And we'll give our VPC a name. I'll call this the class-VPC. And we need to assign it a Cedar network block, 10.0.0.0/18 is what we will use for the network block. This is a network address block that uses a slash notation to denote the size of the network block. Now, I know that traditionally, many students that take this class don't have much experience in networking. And don't worry, you don't need to have a lot of networking experience in this class. Most of the time, I will provide you with the proper network values to plug into things like VPC and subnet configurations. This network block here has to be a private network address range, hence the reason it starts with the number 10, because that represents a private, non-routable network address block. This is something that you might provision within your company or within your home, but you'll never see devices on the internet configured within this 10 network address range. For the IPv6 Cedar block, we're just going to leave that at no. We're not going to set up IP version 6 IP addresses here. Tenancy, we're going to leave at default. This is where we could switch the tenancy from a shared model to a dedicated model. We're going to leave it at the shared default model. I'll click on the Create VPC button, and you will see that a new VPC has been created for us. Now, we have a new VPC, but we can't really begin to use it yet because we can't, when we create something like an EC2 instance, we need to specify which subnet that instance is going to be deployed into. And we don't have any subnets yet. Once we create a VPC, we need to partition that VPC into one or more subnets. And each subnet is associated with a particular availability zone within the region. Let's do that next. We'll click on the subnets navigation link on the left. And you can see that there are a number of subnets already created here. These are the subnets associated with the default VPC. I'll click on the Create Subnet button. And I need to specify the VPC that this subnet's going to be created within. I'll select our class VPC. And we're going to create two subnets. The first one we'll call the class public subnet. And we'll just associate that with US East 1A availability zone. For the network block, we'll use 10.0.1.0/24. This is a smaller network range, which is encompassed within the larger VPC network block. We're taking a slice of that VPC network address range and we're allocating it to this particular subnet. We'll scroll down. I want to add a second subnet, and I can do that here at the same time. I'll call this one the class private subnet. And for availability zone, I'll use the same one, US East 1. For the network block, 10.0.5.0/24 is what I will use. And I'll click the Create Subnet button. And AWS will create those two new subnets for me associated with our new VPC. You can see that each subnet is associated with the VPC, its network address range, and the number of available IP version 4 addresses. Each one of these VPCs could hold roughly 250 EC2 instances, assuming each EC2 instance only had one private IP address. Okay, let's review. We have a VPC, and that VPC has two subnets, one that we're calling the public subnet and one that we're calling the private subnet. By the way, the fact that I call one the public subnet and the other one the private subnet doesn't mean that one is actually public and one is private. That's just simply a naming convention that I'm using. If I want the public subnet to truly be public and the private subnet to truly be private, then I need to configure them so that they align with those desired configuration states. Let's start working on that now. If I click on the public subnet, you can see that the public subnet is associated with a routing table. If I click on the route table tab, you can see the route table and the actual route rule that's currently configured for that route table. Well, where did this route table come from? Because we did not create that. That route table was automatically created for us when we created the VPC. AWS will create a default route table, and anytime we create a new subnet, AWS will associate that subnet with the default route table for that VPC, unless we explicitly associate the subnet with a different route table. You can see that this class public subnet is associated with this default route table, and there is a single route. And the way you read this route is that any network traffic that's destined for this 10.0.0.0/18 network address range, any of that traffic will be routed locally within the VPC. And that network address range is the same address range that we allocated to the VPC. And so another way of thinking about this is that any sort of EC2 instance that I launch and create within this VPC will be able to route traffic to any other EC2 instance. The routing table allows that. That doesn't necessarily mean one instance would be able to communicate with another instance, because that's going to be dependent on security group rules and potentially a network access control list. But from a network routing perspective, that traffic is routable because there is a rule in the routing table which allows for it. Now, if I were to launch an EC2 instance into this public subnet right now, would that EC2 instance be able to communicate out to the internet? The answer is no, because we're actually missing a couple things. Most importantly, we're missing an internet gateway. The internet gateway serves as a bridge between our VPC and the internet. It allows EC2 instances to communicate out to the internet and for things on the internet to communicate with our EC2 instances. Let's go ahead and create that internet gateway now. And I do that by clicking on the Internet Gateways link on the left-hand nav. I click on the Create Internet Gateway button. I name our Internet Gateway. We'll call it Class Gateway. And I create the Internet Gateway. Our Internet Gateway is created. However, it's not associated with our VPC yet. You can see the state of the Internet Gateway says detached, and it's not associated with any sort of VPC. In order to associate it with the VPC, we'll click on the Actions dropdown and click on the Attach to VPC option. We'll search and select our class VPC and click on the Attach Internet Gateway button. Now our new Internet Gateway is attached to our VPC. In summary, we've got a VPC, we've got two subnets, and we've got an Internet Gateway attached to the VPC. Now what will happen if we launch an EC2 instance into the public subnet? Surely that EC2 instance will be able to communicate out to the internet now, right? Well, not quite. We're still missing something. Now we have to configure our routing table so that the routing table has a rule specifying how to route traffic out to the internet. And it needs to route that traffic out to the internet through the Internet Gateway. Essentially, we need to wire up the network connectivity between our subnet and the internet through the Internet Gateway. Let's go back to the subnets list. And we'll click on our public subnet. Click on the route table. And here again, you see there's just one route that says that all the traffic within the VPC itself can all be routed internally. We'll click on the route table ID and then click on the routes tab for the route table. And here we can click on the Edit Routes button and then click on the Add Route button. We want to add a new route out to the internet, and the internet is specified as 0.0.0.0/0. And we want to route that traffic out to the internet through an Internet Gateway. So I'll select Internet Gateway and select our class gateway that we created, our class Internet Gateway. Click on Save Changes. And now our routing table, you can see, has two routes. We have the local route, and then we have a route out to the internet through our internet gateway. Now, if I go back to subnets and click on our public subnet and look at route table, you can see that the route table has a route allowing access out to the internet. Now, if we were to launch an EC2 instance into that public subnet, and that EC2 instance has a public IP address, it will be able to communicate out to resources on the internet. And resources on the internet could potentially communicate to our EC2 instance if it allows that communication through its ingress security group rules. I'm going to click on the subnets link again. Let's take a look at the private subnet. Now, if I look at the private subnet and click on the route table tab and look at this, whoa, this private subnet also has that internet gateway link, but did I create that for the private subnet? I didn't. Well, why is that there? Well, it's there because both the public and the private subnets are associated with the same routing table. When I modified that default routing table and added a route out to the internet through the internet gateway, then that route applies to any subnet that's associated with that default routing table. And the private subnet is associated with that default route table, meaning that it now can route traffic out through the internet gateway. And potentially, if I deployed an EC2 instance with a public IP address in the private subnet, potentially clients on the internet could communicate with that EC2 instance in the private subnet. Now, this isn't a desirable configuration. We want this private subnet to be private, meaning that it won't have direct communication with the internet. And so how do we modify this configuration to remove access to the internet through the internet gateway? Well, I can't go and just modify the routing table again, that default routing table, because it's being used by the public subnet. In this case, what we'll do is we'll create a new routing table, and we'll associate that routing table with the private subnet, effectively meaning that the public subnet and the private subnet will each have their own routing tables that they're using. Let's go create that route table. We'll click on the route tables link on the left-hand nav, click on the create route table button, and we'll create a route table called class-private-RT, stands for route table. We'll associate it with our class VPC. Click on the create route table button, and you can see that it automatically adds that local route, which is what we want. We'll go back to the subnets listing by clicking on the subnets menu item, and then click on the class private subnet. You can see that if I click on route table tab, you can see that the class private subnet is still associated with that default routing table. What I want to do is change that by clicking on the edit route table association button. And I can change the route table from that default one to my class private RT route table. Click on save. Click on that route table tab again. And now you can see that my class private subnet is associated with the class private route table. Okay, let's do a quick recap because I know that we did a bunch of button clicking here. We have a VPC that we've created. That VPC is partitioned into two subnets, a public subnet and a private subnet. We attached an internet gateway to our VPC, and we configured a route in our default routing table to allow instances in the public subnet to route out to the internet through the internet gateway. And then we created a separate private routing table for the private subnet. And that private routing table does not allow EC2 instances in the private subnet to route out to the internet. It only allows internal communications within the VPC. Okay. Well, we're at a point where we can start to experiment with this VPC a little bit. Let's do that by going to the EC2 dashboard, and we're going to create a couple EC2 instances. We're going to launch an instance, Amazon Linux 2. It's going to be a T2 micro instance. For our network, we've been using the default VPC up till now, but now we're going to start using our custom VPC, our class VPC. For the subnet, we're going to use the class public subnet. Auto assign public IP address, we're going to enable that. We want it to assign a public IP address so that that EC2 instance can communicate out to the internet. And we want to assign an IAM role, SSM access, IAM role. Everything else looks okay. We'll click on Next, Add Storage. We'll accept the defaults here. Next, Add Tags. We're going to add a tag. We'll just call it Web Public. Or actually, the key is going to be name, and then the value is going to be web-public. And configure our security group. For our security group, we don't need SSH, so we'll just remove that. We also don't need any sort of ingress access. We're not going to be running anything that's going to be accessible on this EC2 instance remotely, and so we don't need to configure any sort of incoming security group rules. We can review and launch. Click on the launch button. We don't need a key pair, so I'll proceed without one and acknowledge it and launch the instance. Click on the View Instances button, and our instance is now launching. While that's launching, I'm going to launch another one, Amazon Linux 2 AMI, and it's going to be a T2 micro. Configure instance details. We're going to use our network class VPC. For our subnet, we're going to specify the private subnet in this case. So this will be our private instance. Auto assign public IP? No, we don't want to auto assign that. So our EC2 instances in our private subnet, we would never really want to give them a public IP address. So there would never be a reason to do that. We'll assign SSM access for our IAM role and click Next, Add Storage. Select the defaults, add tag. We're going to add a name tag, and we'll just call this Web Private. Security group, remove the SSH security group rule, review and launch button, and proceed without a key pair, acknowledge that, and launch the instance. Okay, we'll go back to our EC2 instances, and we have our public instance here that's launching. I'm just going to pause the video here for a minute while these instances are launching. Okay, at least one of our instances has launched. And they're both running and both is still in the status check initializing phase. But let's start working with them a little bit. We have our public EC2 instance. We'll click on that instance ID and we'll go to connect and click on the connect button. And AWS Session Manager has logged us into the instance. Now, I just want to confirm that the instance is able to communicate out to the internet. I could do that using something like the curl command. If I do curl www.google.com, for example, then I get a bunch of HTML code back. This is the code for the Google web page. This is telling me that the EC2 instance is able to communicate out to the internet. It's able to retrieve information from the Google website. And this is what we would expect, right? We've launched an EC2 instance into the public subnet. That EC2 instance has a public IP address. It can communicate out to the internet through our internet gateway. This is a way that we can quickly test to make sure that the subnet and the routing table and the internet gateway, all of that has been configured properly. I'll go ahead and exit from this instance, close that terminal session, and then go back to my list of instances. And let's test the private instance. I'll click on the instance ID and click on connect and go to session manager and oh, what's going on? The connect button is grayed out. I'm not able to connect to this instance using session manager. And why is that? Why can't I communicate with this instance using session manager? Well, the reason I can't communicate with this instance right now using session manager is because this instance is not able to communicate out to the internet. It's on a private subnet that has no way of accessing the internet, no way of communicating out. And the EC2 instance, this private EC2 instance, doesn't have a public IP address. So even if it had a way to communicate out to the internet through the internet gateway, like even if there was a route in the routing table, the instance still would not be able to communicate out to the internet. And because it doesn't have a public IP address. Well, does that mean that we can't log in and manage EC2 instances that are located in private subnets like this? No, that's not the case. Well, I mean, it could be the case. There could be instances where you create a private subnet that truly has no access to the internet. And these are instances that you don't actually ever log into, and therefore they don't even have AWS Session Manager access. But if you do have instances that are running in private subnets and you want to be able to access them via Session Manager, then you need to figure out a way to give those instances access to the internet in a very secure way. And the way that we do that, the way that we can wire up this private subnet so that we can allow instances on the private subnet to communicate out to the internet, is by utilizing a service called a Nat Gateway. The Nat Gateway is a helper service, essentially, that will allow private instances to communicate out to the internet through the internet gateway. You might be asking, well, again, why can't the private instance just communicate out to the internet through the internet gateway? Well, because the private instance doesn't have a public IP address. because it doesn't have a public IP address, it can't communicate to the internet through the internet gateway. If it only has a private IP address, then it has to communicate out using a NAT gateway. The NAT gateway performs something called network address translation, which will basically allows devices with private IP addresses to communicate with devices that have public IP addresses. If you have like a Wi-Fi router in your home, that Wi-Fi router is doing network address translation. Your workstation in your home, your laptop, your tablet device doesn't have a public IP address. It has a private IP address while it's in your home and connected to your Wi-Fi network, but then it can communicate with the Wi-Fi router, and the Wi-Fi router then can translate and allow your device in your local home network or corporate office to communicate with internet devices. And the NAT gateway is doing something similar. Let's go and set that up next. We'll click on the services link and go back to the VPC dashboard. And in the VPC dashboard, we'll click on the Nat Gateways link. And we will create a NAT gateway by clicking on the Create NAT Gateway button. We'll give our NAT gateway a name. We'll call it our class NAT. We'll associate it with a subnet. And where do we want to deploy our NAT gateway? Well, our NAT gateway needs to be able to communicate out to devices on the internet. And so the NAT gateway needs to live in our public subnet in order to do that. We'll give our NAT gateway an IP address, a public IP address, what's called an elastic IP. And what we want to do that, we can just click on the Allocate Elastic IP button, and that will automatically create, in the background, it created a new elastic IP, a public IP address, and it associated it with this NAT gateway. I'll click on the Create NAT Gateway button, and that NAT gateway was created successfully, and it will take a minute or two for the NAT gateway to become available. You see the state is pending. I'll pause the video and wait here a minute or so while that NAT gateway is spinning up. Given that a minute or two, if I go back to the NAT Gateways link, you can see that the NAT gateway now is available. And we have a NAT gateway that we've now launched. It's running in our public subnet. How do we wire it up so that the EC2 instances in our private subnet can communicate out to the internet through the NAT gateway? Well, we do that by making a change to our private subnet routing table. If I click on the route tables link on the left and go to our private route table that we created by clicking on its ID, we can edit the routes associated with this routing table, and I'll add a new route. And the new route I'm going to add is 0.0.0.0/0, which represents the internet. What we're saying is, in order to route traffic out to the internet, we want to route that traffic out from the private subnet through a NAT gateway. I'll select the NAT gateway target, and I'll select our specific NAT gateway and click on Save Changes. And now our private routing table is able to route traffic out to the internet through a NAT gateway. The way to think about it is that the network traffic is going from that private EC2 instance to the NAT gateway to the internet gateway, and then eventually out to an internet location. Let's go back to our EC2 dashboard, and we'll go to our web private instance, click on connect, and you can see that the session manager still is grayed out here. Now, in my experience, this can take a few minutes before the session manager access becomes available. So I'll pause the video here at this point. I did a minute or two, and what I had to do is I went back to this web private instance, clicked on connect, and I had to refresh my browser. And once I did that, then the connect button became available. Click on that button, and now I am logged into that private EC2 instance. And again, that private EC2 instance has a private IP. It lives in the private subnet, but I'm able to access it via Session Manager because I set up that Nat Gateway. Now, you might be asking yourself the question, like, well, what if I want to set up private EC2 instances on a private subnet, but I don't want to provide those, I don't want to allow those EC2 instances to communicate out to the internet. And yet I want to be able to access them via Session Manager. Is there a way to do that? And the answer is yes. There is a way to do that using a service called Private Link that we won't cover in this course. But there are options to set up that sort of configuration. You might also be asking yourself, well, now that we have a Nat Gateway in place, doesn't that allow clients on the internet to potentially communicate with our private EC2 instance? The answer is no. The Nat Gateway does not support incoming requests from the internet, and does not proxy those incoming requests and distribute them to something like a private it doesn't distribute it to the private EC2 instance. So it's not serving, acting like a load balancer or something like that. You can think of the network connectivity is really one direction. It has to be initiated by the EC2 instance outgoing to some device on the internet. Well, I'll go ahead here and exit from this private EC2 instance. And let's go ahead and kind of wind these things down that we created. I'll go to the instances and select my instances, change the instance state to terminate because I no longer need those EC2 instances. And next I'm going to go to the VPC dashboard, and I want to delete the Nat Gateway. I'll select the Nat Gateway and say action delete Nat Gateway, and I can type in delete in the field to confirm, click the delete button, and we'll go ahead and delete that Nat Gateway. Now, when we created the Nat Gateway, what we had to do was automatically allocate an elastic IP to that Nat Gateway. When we delete the Nat Gateway, AWS does not automatically delete that elastic IP. It'll hang around in our account. And if that elastic IP isn't attached to something, then AWS will charge us a fee, a monthly fee, for basically having that elastic IP allocated. traditionally they've charged $1 a month for that elastic IP. Again, if you're not using the elastic IP, then you get charged for it. If you are actually using it and it's attached to something, then you don't get charged for it. In effect, they penalize you for hoarding elastic IPs. What we can do to get rid of that is we can click on the elastic IPs link on the left. Here's our elastic IP that was allocated, and we can go to actions and say release elastic IP addresses. And that will release the elastic IP address back to AWS, and AWS can then provide it to some other customer that requests it. Okay. How do we get rid of the VPC stuff? We've got a VPC and subnets and routing table. Fortunately, AWS makes that pretty easy. If you go to your VPCs and select the VPC that you created, you go to actions, delete VPC, then it will tell you everything it'll delete the VPC and all of the networking stuff that's associated with it. Now, if you are still running something within the VPC, like if I had an EC2 instance still running in the VPC, then AWS would not allow me to delete the VPC yet, and it would give me a warning message. But because I deleted those instances, I deleted the Nat Gateway, now I can also delete the VPC by typing in delete in the delete field and clicking the delete button. And that will go ahead and delete everything in my custom VPC, which is something that we'll do in each of our projects. We'll create a new custom VPC, and then when we're done working with the project, we'll go ahead and delete that VPC. I hope that this hands-on segment was helpful for you, and I hope you're ready for the next one. Thanks.